welcome to the Explainer. You know, we hear the terms smart factory and smart machinery thrown around all the time, but what's really going on under the hood? Today, we're going to break down what truly makes a machine smart and why it's the absolute foundation of any modern smart factory.
Okay, so let's just dive right in. When you get right down to it, what's the one thing that separates a truly smart machine from a traditional one? Well, at its core, the answer is actually surprisingly simple, but it changes absolutely everything about how we manufacture things.
Yep. The biggest difference is that one has a brain and the other, well, it just doesn't. It's a simple idea, right? But this one little addition completely redefines what a machine is even capable of doing.
Now, take a look at this because it shows you the difference in the hardware. See, every machine has a PLC, a programmable logic controller, to handle the moving parts. A traditional machine pretty much stops there, using a simple screen for an operator. But a smart machine? It adds an industrial PC, or IPC, and that is the brain we're talking about.
So here's how we're going to break it all down. First, we'll get a closer look at that brain. Then, we're going to put these two types of machines head-to-head. After that, we'll dig into why we even need this tech in the first place. And finally, we'll look at what's next and the challenges that come with it.
All right, let's zoom in on this brain, the industrial PC, and really understand why it's such a massive game changer.
First off, let's be clear about the PLC. It's the tireless workhorse in pretty much every machine, controlling all the physical stuff like motors and valves. And it is incredibly reliable for executing a rigid, pre-programmed script. But that's the key. That's all it can do. It just follows orders. It can't think for itself. And this is where the IPC comes in. You can think of it as a super tough, powerful computer that gives the machine the ability to think. It can run complex software, chew through tons of data right there on the factory floor, and talk to the outside world just like your computer at home can. It moves way beyond a simple script into making dynamic decisions on its own.
So now, let's see how this difference actually plays out in the real world. Putting these two machine types side by side really highlights what that brain makes possible.
And this table just illustrates the divide perfectly. A traditional machine, it really struggles to communicate. If you want to change the product you're making, you have to stop the whole line for a manual adjustment. But the IPC-powered machine, oh, it's a whole different story. It can switch production recipes on the fly and even process data right there at the source. That's something called edge computing. It means decisions get made way faster without having to send everything to the cloud and back.
Okay, so this is the crucial question, right? Why does any of this even matter? Why do we need machines that can talk and process data? What's the big picture here?
Well, it all boils down to meeting the one central demand of our modern economy and Industry 4.0, mass customization. We, as consumers, want products tailored specifically for us, but we want them at the speed and cost of mass production. That is the huge puzzle that smart machinery is built to solve.
Just picture this workflow for a second. A custom order comes in. A new production recipe gets sent directly to the machine's brain. The machine instantly adjusts its own settings, and just like that, it produces that one unique item. And the best part? The line never stops. This is a universe away from the old way of doing things, shutting down the entire line just to manually reconfigure one machine, which is a massive source of lost time and money.
This quote really gets to the heart of it. When machines have a voice, when they can communicate their data, their status, their performance in real time, management can finally stop guessing. Your decisions become faster, way more accurate, and ultimately a whole lot more powerful.
So now let's look at where all of this is going. We've defined the tech, and we know its purpose. But what does the future actually look like? And what are the real-world roadblocks stopping us from getting there?
I mean, the vision is truly incredible. We're talking about machines that can predict their own failures and schedule their own maintenance. Machines that can be serviced remotely by the company that built them from halfway across the world. We're even talking about machines that can automatically tweak their own settings from one job to the next to maintain perfect quality.
But here comes the reality check. For all this incredible potential, upgrading an entire factory isn't as simple as just flipping a switch. And this is where a lot of smart factory projects just hit a brick wall. The reality is, these upgrades are expensive. Most factories are a jumble of new and old equipment, and a lot of those older machines are super specialized and still work perfectly fine. A full rip and replace, just throwing out every old machine, is almost never a practical or financially smart option.
So what's the key takeaway here? It's this. The smart machine is the destination, for sure. But the journey there isn't about replacing everything all at once. The real challenge, and the real opportunity, is creating a strategy that bridges the equipment you already have with the technology of tomorrow. It's about building a smarter factory one intelligent step at a time. So the question isn't just if your factory is ready for the future, but how you're going to build that future piece by piece.